All right, are you ready to really step into the shoes of a coding master? Today we're diving deep into refactoring with, you know, Martin Fowler's legendary book, as our guide.
It's going to be like we're channeling Martin Fowler,
Mm,
explaining all his insights on how to transform code from just good to mind-blowingly awesome.
yeah, I love that idea. So we're going way past just skimming the surface, right? We're going deep, deep down into the the how of refactoring.
Exactly. We really want to grasp the essence of this practice. And speaking of the essence, Fowler, he starts off with a really powerful statement that I think sets the stage for the whole book. He says, any fool can write code that a computer can understand, but good programmers write code that humans can understand.
Ooh, okay. Strong opening line. It really highlights that, that code is for humans too, not just, machines.
Yeah. It's easy to forget that when you're, deep in the technical stuff. But code is meant to be read and understood by other people, to be maintained.
True, true. But let's be real, sometimes you just got to crank out features, right? Who has time to make code pretty when you've got deadlines breathing down your neck?
I hear you. And that's where this idea of the design stamina hypothesis comes in. Fowler, he says that spending time on good design, through refactoring, actually helps you deliver features faster and with fewer bugs in the long run.
Wait, so you're saying that refactoring actually makes us more efficient? How does that work?
Okay, so think of it this way, right? Imagine you're building a house. If you rush through the foundation and framing, you're not paying attention to the design, you might get the walls up fast, but you're going to end up with a shaky structure. And then it's hard to change or extend it later.
Okay, I'm kind of seeing the analogy here. So poorly designed code, it's like a house with cracks in the foundation. Might stand for a bit, but eventually.
It's going to crumble. Exactly, exactly. And just like with a house, fixing those problems after everything's built is way more expensive and time-consuming than getting it right from the start.
Right, so refactoring is like investing in a solid foundation. It lets our code grow and adapt without, falling apart.
Yeah, and that's the real benefit here. Fowler argues that well-designed software, the kind that's regularly refactored, it keeps its development speed, maybe even gets faster over time. He calls this design stamina.
Design stamina. Interesting concept. So we can actually keep moving fast as our code base grows.
Exactly. But okay, let's talk about the elephant in the room, right? The fear of messing things up, introducing bugs while you're refactoring.
Yeah, that's a real concern. It's like rearranging furniture in a dark room. You're bound to trip over something.
And that's why Fowler is so big on testing. He says refactoring has to be done alongside thorough testing, like automated testing if possible.
So it's like a safety net, right? If we make a mistake while we're refactoring, the test will catch us.
Exactly. He talks about this idea of self-testing code, where the tests are so integrated that they're like a bug detector built right in.
Okay, cool. So testing's our safety harness. But how do we know where to start refactoring? What are the warning signs?
That's where Fowler's concept of code smells comes in.
Code smells like something's gone bad in the fridge.
Aha, yeah. It's not that they're actual bugs, but they're these indicators, little hints that the code's design might be, a bit off.
Got it. So there's signs that we should probably take a closer look before things get out of hand.
Right. And Fowler, he's identified a bunch of these code smells. Each one kind of points to a potential area for improvement.
Okay, I'm definitely intrigued. Give me some examples. What should I be on the lookout for?
Well, a really common one is duplicated code. You know that feeling when you find yourself just copying and pasting the same code over and over?
Oh, yeah, definitely. It feels good at the time, like a shortcut, but then later?
It comes back to bite you, exactly. You've got multiple copies of the same logic all over your code, and then if you need to change it, nightmare.
Oh, yeah, total nightmare. So duplicated code, that's one to watch out for. What else?
Another one is long function. Ever run into a function that just seems to go on forever? You're scrolling and scrolling.
Oh, yeah, those are like black holes. You get lost in them.
Right. Super hard to understand, hard to debug. A sign that the function's doing too much.
Okay, so duplicated code and long functions. Got it. What else should I be sniffing out?
Large class is another big one. Imagine a class that's trying to do way too much, like a Swiss Army knife with a million attachments.
Ah, okay, I get it. Too much going on in one place.
Exactly. Hard to understand, hard to maintain, and they often violate the principle of single responsibility. Each class should have just one specific purpose.
All right, so we've got duplicated code, long functions, and large classes. Anything else to add to my code smell list?
Let's not forget about too many comments. Comments can be helpful, but when there are too many, it can be a sign that the code itself isn't clear enough.
Oh, so it's like when you have to explain a joke.
Yeah.
You got to explain it. It's not funny.
Uh-huh. Exactly. If you're writing paragraphs of comments, it might be time to refactor and make the code itself easier to understand.
Okay, so we've got duplicated code, long functions, large classes, and excessive comments. That's a pretty good starter kit for my code smell detector.
Yeah, it is. But remember, recognizing the smells is just the first step. The real magic happens when we start applying Fowler's refactoring techniques to actually, eliminate the smells and improve the design.
Okay, I am so ready to roll up my sleeves and get refactoring.
So now that we've, fine-tuned our noses to sniff out those code smells, let's get into like the actual tools, right? Fowler, he gives us this amazing catalog of refactoring recipes. It's incredible. Each one is designed to like target specific design flaws,
Yeah.
and make our code better structured overall.
Refactoring recipes. I love that. It makes it sound way less intimidating, like we're baking a cake or something.
Yeah, right. And like a good recipe, Fowler gives us these clear steps to follow. Make sure we're making those changes safely, effectively. So let's start with, I think, one of the most basic ones, extract function.
Extract function. Okay, sounds pretty self-explanatory, right? We're pulling out chunks of code, putting them into their own functions.
Exactly. But there's an art to it. You're not just randomly chopping up your code, right?
Yeah.
The real key is to look for code that does one specific thing, you know, as a clear purpose, something you can describe with a really good, concise name.
So it's like taking this long, rambling paragraph and breaking it down into shorter, more focused sentences.
Perfect analogy. And just like with good writing, right? Well-structured code is so much easier to read, understand, and work with later on.
Okay, I'm seeing the value here.
Yeah.
But how do we choose, like, the right chunks of code to extract? Any wisdom from Fowler on that?
Yeah, he suggests you ask yourself, what does this chunk of code actually do? If you can answer that with a simple, clear sentence, you've probably found a good spot to extract.
All right, so let's say I found a piece of code that, seems like it's ready to be extracted. What's next?
This is where the recipe part really kicks in. You got to look closely at that code, see if there are any variables being used in that chunk, but declared outside of it.
Right, like making sure our new function has all the ingredients it needs. We can't send it off to bake a cake without flour and sugar.
Haha, exactly. So those variables, they need to get passed into the new function as parameters. And if the code that you're extracting changes any variables, you'll need to handle those too, usually by returning the modified value from the new function.
Okay, got it. Pass in the ingredients, get back any changed values, and bam, we have a new function. But we're not just like mindlessly extracting, right? We're giving this new function a good name.
Absolutely. That's a big part of this. A well-named function, it's like a signpost in your code. Makes the whole thing easier to follow.
Right, so no more of those mysterious function names like do stuff or calculate thing.
Nope, no more of those. You want names that are clear, concise, and tell you exactly what the function does. Fowler even says, a good name is a self-documenting piece of code.
Okay, I'm really starting to see how this all comes together. But let's say I've got a function and it's already pretty short, pretty simple. Should I still try to extract it?
That's a great question, and it brings up another important point. Knowing when not to refactor. Sometimes a function is so clear that extracting it would just make things more complicated,
So it's like finding a balance, not overthinking things.
Exactly. And Fowler, he actually has a refactoring specifically for those times when a function is too simple. It's called inline function.
Inline function. So it's like hitting undo on an extract function.
You got it. If the function's name is already doing a good job of explaining what the code does, sometimes it's just clearer to put that code right into the calling function. Again, it's all about making things as easy to read as possible.
Okay, it makes sense. So we've got extract function for, breaking things down, inline function for keeping things simple. What other refactoring magic can Fowler teach us?
Let's talk about replace temp with query. This one helps get rid of temporary variables that are only there to hold the result of some calculation.
I think I've seen this one. Instead of creating that temporary variable, we just call a function that does the calculation and gives us the result directly, right?
Exactly. And just like with extract function, we're not just moving code around, we're making it more readable. We're giving that new function a good name. So it's like swapping a confusing formula with a clear label.
It's amazing how much of a difference these small changes can make. They really do make the code so much easier to work with. So what else can we do to tackle complexity and make our code better designed?
All right, let's look at something called introduce parameter object. Imagine you've got a function and it takes a ton of parameters.
Oh yeah, I've seen those. It's like this massive list, hard to even keep track of what's what.
Right, and that's where introduce parameter object comes in. Instead of passing all those separate parameters, we just bundle them up into an object.
So it's like taking all those ingredients and putting them into one container.
Exactly. Simplifies things, makes the code less cluttered and less prone to errors. Plus, if you need to add or remove parameters down the line, you only have to change the object, not every single place you're calling the function.
Super efficient.
Yeah.
I can see how useful that would be, especially in more complex systems. Fowler really is like a code wizard.
He is. And we've only just scratched the surface. There are so many more techniques to learn, each one offering a unique way to improve our code's design and flexibility.
I'm already feeling inspired to go back and rework all my old code.
Yeah.
But before we do, let's keep exploring. There's still so much more refactoring wisdom to uncover. All right, I'm ready for more. Hit me with some more of Fowler's refactoring wisdom.
Okay, let's try one that sounds a little scary, maybe. Replace conditional with polymorphism.
Polymorphism. Whoa, that sounds kind of intense, like something from a sci-fi movie.
It might sound like it, but it's a really cool idea. It's all about using inheritance, object-oriented programming to make those messy if-else statements way simpler.
Okay, now I'm curious. How does polymorphism help with that?
So imagine you've got code with a ton of if and else branches. Each one handles like a different type of object. As your code gets bigger, this can become a real pain to manage.
Yeah, I can see that getting out of control fast, so much repetition, so many special cases to remember.
Exactly. So polymorphism lets you define different behaviors for each object type, right? You don't need those big conditional blocks anymore. Instead of one giant function doing everything, we let each object type handle its own stuff.
Oh, so it's like having specialized chefs for each dish instead of one cook trying to make everything at once.
Perfect analogy. And the best part is, when you add a new object type, you don't have to mess with the existing code. You just make a new subclass with its own behavior, and the system just adapts. Really powerful, really elegant.
Wow, that's some next level stuff. Our code's like evolving into a smarter, more adaptable being. But before we get too lost in the abstract, let's bring it back down to earth. How about we talk about move function?
Yes, move function. This is about finding the right place for a function, like in your code base. Sometimes as you're refactoring, you realize a function just logically belongs somewhere else, maybe in a different class or module.
Like when you accidentally put the gardening tools in the kitchen drawers and you're like, nope, these belong in the shed.
Exactly. And move function gives you a safe way to do that. You figure out what the function needs, where it should go, and then you move it carefully, testing as you go.
Sounds like a delicate operation, but I can see how it would make your code a lot more organized in the long run.
It definitely does. It's all about having a code base where everything has its place, so it's easier to understand and work with.
Man, this has been an amazing journey through the world of refactoring. So many powerful techniques, from the basics to the really advanced stuff. I feel like I've got a whole new understanding of how to write good code.
Me too. And it's important to remember, refactoring isn't just about fixing problems or cleaning up messy code. It's about continuously making our software better, more adaptable. It's about embracing change and building systems that can evolve gracefully over time.
It's like we're not just coding, we're creating these living, breathing systems.
Exactly. And that's why refactoring is so crucial. It helps us build software that can last. Software that's not just functional, but also beautiful, elegant, a joy to work with.
I love that. So as we wrap up this deep dive, what's like the one big takeaway you want our listeners to remember about refactoring?
I think Fowler nails it when he says refactoring is a journey, not a destination. It's an ongoing process. It's this mindset of always trying to improve, something we can do throughout our careers as developers.
Yeah. Couldn't have said it better myself. Thanks for taking us on this incredible journey through the world of refactoring. It's been a real eye-opener.
You're very welcome. Happy refactoring, everyone.